Okay, it's 11 o'clock. Good morning, guys. Welcome back. Please, I hope you can hear me. If you can't hear me, do let me know. Okay, so as you know, right, we have our first exam coming up this Wednesday, right? This Wednesday. Now, I'll spare the last 7 minutes of the class to talk briefly about it, right? So as I told you earlier on, the review, the solutions to the review, and you can find that like on the canvas, right? I've posted a study guide and then the solutions there. I tried to do step by step, but I'll talk more about it the last 7 minutes. So if I'm also missing the last 7 minutes, let me know, right? Draw my attention. So I'm going to end the lecture actually on at 11:43. And then for the last 7 minutes, we'll just talk about the exam and what you expect. Okay, please, do you have any comments or questions before we begin today's session? Okay, so if there are no comments, then let's continue from where we stopped the last time. Please, I'm sharing my screen. If you can't see, do let me know. Right. So last week we learned a very important formula when we are trying to obtain what the slope of the tangent line or the instantaneous velocity. We said that the derivative, it is something we call a derivative, right? And the derivative of a function f at a number a, which is denoted by this, and it's read f prime of a, is given by what? So you just write the f prime of a is given by the limit as h approaches 0 of f of a plus h minus f of a all over h. As I said, you need to memorize this going into the exam. It's very important. You do something on this, right? Okay. So we said we obtained this one as a much more convenient formula from this formula, right? These are serving the same purpose. It's just that this is more convenient to use, right? So this is what you'll be using. Yeah, so we did this last week. Now this is an example, right? So example 4. The example asks us to find the derivative of this function at the number a. Let me see if they have the solution is here. So that means I'll work it on the whiteboard, right? So let me go to the whiteboard. 2.7. This is example 4 on slides. Okay, so the question is saying we are given that the function, right, in function notation, that's f of s equal to s squared minus 8x plus 9. And then we are interested in the derivative at the number a. So this example is just going to be like what you get on the exam, right? You'll be using the formula and then you'll be finding the derivative at the number a. So at the number a. Oh, let me see. People are coming in. Okay, all done. Okay, so when you're given this, right, as I said, please do not use the rules. You've not studied the rules yet. Maybe you took calculus, you've taken calculus before, right? But if you have, please don't use the rules. We've not studied those yet. If you use the rules, then it merits no point because the question will say using the definition of a derivative, right? So if the question says using the definition, you must use the limit as h approaches 0 of f of a plus h minus f of a all over h. That's the formula that is required, right? So please note that. So this one is asking for the derivative, right? So this is the solution. The derivative at a. So we need f prime of a. So what is the formula? The formula is what? The limit as h approaches 0, f of a plus h minus f of a all over h, right? So we have to know this formula. So this is where we start from. Okay, so now that you have the formula down, right, you need to what? And also you are not allowed formula sheets on the exam too. So yeah, so that's it on that. So we just need to find the f of a plus h, the f of a, and then try and find the limit, right? So let's try and get the f of a plus h. What is that? Now for f of a plus h, right, in the function notation, wherever you see x on the right-hand side, you plug in the a plus h for x, right? So that means that this is going to become a plus h all squared minus 8a plus h and then plus 9, right? So let's try and simplify this, right? So for this one, if you multiply this out, you can use the FOIL technique, or you can use the fact that this is the square of a binomial. For the square of a binomial, what you have to do is just square the first term. So that would be a squared plus 2. Multiply the two terms. So that would be a and h. And then plus square the last term, right? So that's a very fast way of doing this. And then for this part, I'll distribute the negative 8. So that would be minus 8a, and then negative 8, and then h will be minus 8h. And then I have plus 9, right? So this is f of a plus h. Where did I get the a plus h? Okay. Okay. So where did I get the a plus h? So let me talk in entirety. I don't know exactly what you want, but I'm going to talk in general so that you pick the answer for what I'm saying. So you know this is the formula you have to use, right? You get this formula part. This is the formula. Okay, so we need this one, right? The f of a plus h, and we need the f of a. So where do I get the f of a plus h? I get it from here. I'm giving f of x to be this. So f of a plus h is this the a plus h, which is replacing the x, right? So wherever you see x here, you put in a plus h. Let me see. I think I see something in the chat. Oh, you saw him for f. Okay. Yeah. So I'm just finding f of a plus h. Yeah, f of a plus h instead of f of x, right? The f of s is this, x squared minus 8s plus 9. F of a plus h is the a plus h is replacing the x. So on the right-hand side, wherever you see s, you put in a plus h, right? Okay. Please, any other questions? Okay. Now, I don't want to put this f of a plus h directly here because it will be too long. So let me just find f of a. Let me find f of a. So maybe let me ask you this, right? For f of a, what will it be? Can anyone please help me with this? You can unmute yourself and speak, or you can send me a chat. Either one works. So f of a, what would this be?
I think it will be a square.
A squared.
Minus 8a.
Yes.
Plus 9.
Perfect. Thank you so much, Daniel. Yeah. So it will be a squared minus 8a plus 9, right? So now that we have f of a plus h and f of a, this formula, if you plug it in, it may be too long. So maybe for convenience, let me just do the f of, I mean, you can still put it in, no worries there, but let me just do this one so that it will represent the numerator, right here. So that when I'm done, I can just put it there. So let me simplify this right here. So with this part, you are doing f of a plus h minus f of a. So let's subtract, right? So let's subtract. So what do I see? I see a squared here and a squared here. So if I do f of a plus h minus f of a, the a squares will cancel out. I see minus 8a, I see minus 8a, so those will also cancel out. I see 9 here and I see 9, so those will cancel out. So what will be left are these terms, the 2a plus h, and then plus h squared, and then minus 8h, right? So that means that for the f of a plus h, I'm going to have 2ah plus h squared minus 8h minus 8h, like so. So now let me put everything together and find f prime. So f prime of a will be equal to what? The limit as h approaches 0. And then f of a plus h minus f of a, I've already done this, right? If I didn't do it earlier on, I'll have to write that long thing here, right? I mean, which is okay if that works for you, but I like to simplify it as it comes. So I have 2ah plus h squared minus 8h, like so, all over what? The h. Please, are you okay up to this point? Any questions? Okay, so now at this point, we have to what? Just find the limit, right? So for this limit, as I told you, for the derivative, you're always going to get a type 0 over 0, right? So you just have to think about simplifying and solving, right? How is f of a equal to that? Okay. How is f of a equal to the a squared minus 8a? Okay, so let me do this on the side. So what I'm saying is f of x is equal to s squared minus 8x plus 9. Do you see? So if you're asked to find f of a, replace the a with x on the right-hand side. So that means wherever you see x, you put in a. Do you see? So that will become a squared minus 8a plus 9. Please, does that make sense now? Or still? Okay, you get it. Perfect. Nice. Okay, so So where are we? We are continuing with f prime of a, right? So as I was saying, for the f prime of a, for a derivative, you always end up with type 0 over 0. So you just have to be thinking about how to simplify, right? By canceling out common factors and then plugging in again. So let me take away this equal to and continue from here. So that'll become the limit as h approaches 0. And then for the top, I can see that there is an h factor here and there. You see? So that means I can factor out an h. And then I have what is left on this term. It is what? 2a. And then what is left here, if I factor out an h, is just h. And then what is left here, it's just minus 8. Right? And then all over h. Please, are you okay up to this point? Does it make sense? Any questions? Okay. So then with that one, at this step, right, you can cancel out h like so. And then you just have this equal to the limit as h approaches 0 of 2a plus h minus 8. Please, any questions up to this point? Okay. Now, anybody needs time here? Okay, then let me move on. So then, on the next slide, we have f prime of a equal to what? The limit as h approaches 0 of, what's there? 2a, let me rewrite this and then evaluate. 2a plus h minus 8, right? So what do we do again? We try and plug in. So at this stage, right, you are trying to take the limit as h approaches 0. So you plug 0 for h in there. So you're going to get 2a plus 0 minus 8. So that's simply 2a minus 8, right? So that's f prime of a, and that's it. So we'll be doing something similar to this on the exam. Please, any questions on this? Is it f prime of a because the question is to find the derivative? Yes. The question is asked, yes. It's f prime of a because the question is asking us to find the derivative, yeah, at the number a, right? Because we define the derivative as what? At a, as that f prime of a. Right. Please, I hope it makes sense. Do you have any follow-up questions? Oh. Oh, okay, cool. Please, anybody needs time here? I hope you're okay. Okay, then let me go back to the PowerPoint, right? So this is just nice notes. We are just going to recap it. I think this one, it has room, so it will write everything on the numerator. So you are asked to find the derivative, right, at the number a, but you already defined that as what? The derivative of a function at the number a is given by this formula, right? So first you acknowledge the formula. This is the formula. We need to memorize this, right? And then from there, you try and find you try and evaluate the limit. So what do you need? You need f of a plus h. Now, because f of x is s squared, 8s plus 9, for f of a plus h, wherever you see x, you put in a plus h, right? So that's a plus h squared minus 8a plus h plus 9. And then minus what? The f of a. For the f of a, wherever you see the s, you put in a, right? So that's what you see here. And then when you simplify, this was I was trying to avoid. That's why I did the f of a plus h minus f of a before I put it in the limit. Else you get something very long. But it's up to you. If you want to leave it in that form, that's also perfect, right? So with this one, you simplify everything and you get this. And then you can see there are common factors of h here, right? And that will leave you to this, right? And then finally, you plug 0 for h, and that gives you this. Okay. Now,
I have a question. So can you just replace like x with a, like for the final answer? So it'd be 2x minus 8.
Okay, that's a good question. Thank you, Anta. So, because the question asks for f prime of a, you have to give it
okay
2a minus x. If the question had asked for f prime of x, then
all
you
right,
x minus 8.
And for the exam, do we have to do all of the limit work or?
Yeah. So that one, this question will come in the written part. A question similar to this will come in the written part. So you have to show all your work, right? Because our award points according to that. And you cannot use the rules. Do you see? Yeah. So you have to do all the work for this.
Okay. Thank
Okay.
you.
You're welcome, Manta. Okay, please, any other questions here? Okay, anybody needs time? Okay, so now, as I was saying, now that we know that the derivative is the same as the derivative at A is the same as the slope of the tangent at A, is the same as the instantaneous velocity at A when the f is a position function, right? So that means that now that we know that f prime of A represents the slope of the line, that means that if you have a point, you know that if you have x1, y1, and you have the slope, then what is the equation of this line? The equation is y equal to what? Sorry, is it? I can't erase when I'm here, so let me go back here. Erase, draw. Okay, I think I have it now. Let me go. Yeah. Okay, yeah. So if you have a slope and you have a point, then you can use the point slope formula, right, to write the equation of a line as what? Y minus y1 equal to mx minus x1. You see? So now that we know that the slope is the same as what? The f prime, the slope of a tangent at A is f prime of A. It leads to this formula, right? So we have this is the slope, right? And then you have x minus A. Right, the S1 is the A, right? Because when you are interested in the slope of the tangent line at A f of A, then the f of A is your y1, and then the A is your what? X1, and then your slope is what? F prime of A. So with these ingredients, you can just use the point slope formula to get the equation of the tangent line as y minus what? F of A equal to what? F prime of A, and then x minus A. Please, I hope this makes sense. Okay. Any questions here? Anybody needs time? Okay. Now, this last concept is going to generalize what we mean by derivative. So we've seen that the derivative at A or f prime of A is the same as the slope of the tangent line at A, right? At a point A, f of A. And then the derivative at A is also the same as the instantaneous velocity at what? At A, right? But it turns out that these are not the only two cases which we can apply the derivative. As I told you last week, the derivative can also represent something we call an instantaneous rate of change. So to look at that, let's look at rate of change. What do you mean by rate of change? So if you have a function y equal to f of x, right, for some quantity, right, f of x, and then you know that the x changes from x1 to x2, right? This is called an increment of x. So you're changing from the x from s1 to x2. Now, in that case, the increment of x will be given by s2 minus x1, right? And then the corresponding change in y will be given by what? The f of x2 minus f of x1, right? So these are just changes, right? So that's the notation. You see the delta x and then uppercase delta y, right? So that's the change in s, change in y. Now, if we are interested in the difference quotient of this change, right, then we have the change in y over change in x, and that will be given by f of x2 minus f of s1 over s2 minus s1. So for any quantity f, this is the difference quotient. Now, this difference quotient, as you can see, is quite close to what? Slope of a line. It's also close to what? What do you call it? Average velocity. Right? Do you see? If the f is a position function, then this is just the average velocity formula. If the f is the equation of a curve, this is just what? The slope of a line. Do you see? So this difference quotient is a more general definition of something of this nature, right? Where you have the change in y over change in x. That is called the difference quotient. So for this one, this is called the difference quotient is called the average rate of what? Change of y with respect to x. That's why when the f is a position function, this is called average velocity, right? So it's an average rate of change. So in general, it's called an average rate of change, right? Over the interval s1 to s2. So as I was saying, this is interpreted as what? The slope of the secant line if we are looking at f being a curve, right? So in the long run, now don't be worried about the calculations here. The calculations are the same. As I said, this whole section is just about the f prime of a being equal to what? Limit as h approaches 0 of f of a plus h minus f of a all over h. But all of these are just ways of defining them, right? So don't worry too much about the processes here. I'm not going to ask you to prove anything or anything. I'm just showing you why it makes sense in several fields, right? So now let's go. Now, suppose we are interested in the instantaneous rate of change of y with respect to x, given this difference quotient. Then the instantaneous rate of change is just going to be what? The limit as what? The S2 approaches X1. In other words, we can say as the S2 approaches the S1, then the difference between the two of them is what? Is getting close to 0. So that's why you have this here. Delta S is approaching 0, right? Because as 2, let me go back. As X2 approaches X1, as they get closer and closer, this increment is approaching 0, right? So that's what you see here. So as the increment approaches 0, then the change in y over change in x, right, is just going to be what? The limit as S2 approaches x1 of f of s2 minus f of s1 over s2 minus s1. So what is this? As you can see, this is clearly what? The f prime of x1, right? Looking at the formula, and the formula we developed earlier on for instantaneous rate of change or the slope of the tangent line. This is the same formula, right? It's f prime of x1. Now, this leads to another conclusion that the derivative at A is not just the slope of the tangent line at A. It's not just an instantaneous velocity at A. In general, the derivative at A also has a second interpretation, right? We can interpret it as what? As an instantaneous rate of change of y with respect to x when x is equal to A. So instead of calling this a slope of the tangent line or instantaneous velocity at A, we can also interpret it as what? An instantaneous rate of change of the function. So this is more general. This is a more general way of looking at it with respect to x at s equal to A. Please, are you okay with this? So this is just leading to this. As I said, I won't be asking you to prove anything. I'm just leading to this, right? But the most important thing you have to take away from here is that formula, the f prime of A, its interpretation that is the slope of the tangent line, instantaneous velocity, and also the fact that the formula is given by what? F prime of A equal to limit as h approaches 0 of f of A plus h minus f of A all over h. So that's the takeaway. Please, any questions on this? So that's 2.7. Okay. Anybody needs time on any part? Okay, then let's continue. Please, I'm sharing the 2.8. 2.8 slides. If you can't see, do let me know. These slides are on Canvas. Yeah, I post them on Canvas, Donovan. Yeah, everything is on Canvas. So after the class, I'll post everything. The whiteboard and the PowerPoint. Yeah. You're welcome. Okay, so 2.8. Now, for 2.8, we are going to look at the derivative as a function, right? The derivative as a function. So in 2.7, you saw this formula. We said that when we are looking at the slope of the tangent at the point A, or the derivative of the function at a point A, then it's given by f prime of A equal to the limit as h approaches 0 of f of A plus h minus f of A all over h, right? So this at a number A, right? At a number A, at a number A, you see, a number, this is a number A. So that means that when you're looking at the curve, you're interested in the slope of the tangent at just one point A. Well, it turns out that we can also be interested in the slope of the tangent across the entire curve, right? So not just say at a specific A, but let's say the A was 1, right? If the A is 1, it's just at only 1, the slope of the tangent at only 1. Suppose you're interested in, say, the slope at 2, at 3. Let's say the function is defined for all real numbers, and you're interested in what? The slope or at any point. Then we are just going to replace this number A here with x. So a variable x, right? So that if we get this formula, if we are asked to compute the slope of the tangent at any point at all, we have the formula. We can just plug it in and then we get our formula, right? So suppose you have, say, f prime of s equals to, say, 2x, and you're asked to find out the slope of the tangent, at, say, 1, slope of tangent at 1. Right, then all that you do is just do f prime of 1, and you have 2 times 1. You don't have to go through the whole process again, right? So this is what we are talking about now. So you are just replacing the A with x. That's f prime of x. So if you're replacing the a with x, then the formula will be a little bit modified. It just limits as h approaches 0. And then we saw a here, so that will be replaced with x. And we saw another a here, that will be replaced with x. So we are basically doing the same thing as 2.7, but we are just changing the a for x. That's all. Right. Please, anybody needs time here? Okay. Now, why do we call this a derivative? Well, we call this a derivative because this new function f prime of s that we have now is what is derived from f, right? It's a function derived from f. It depends on the f. As you can see, what is f prime? F prime of s is what? F of s plus h, f of, it depends on the f, right? So it's derived from the function f. That's why it's called what? A derivative, right? So we can interpret this as you saw in 2.7 that this is just the slope of the tangent line to the graph at the point x f of x, right? So that's f prime of s. That's what it means. Is the slope of the tangent line to the graph f at a point x f of x. So don't forget in 2.7, we're saying f prime of a is the slope of the tangent line at the point a f of a. So if you replace the a with x, right, then the interpretation still holds by just replacing the a with x. So f prime of s will be what? The slope of the tangent line at a point what? X f of x. And it will be called f prime of x. You see? Yeah, so that's it. Now, one thing about the domain of the f prime is sometimes it can have a smaller domain than the original function. The domain could also be the same, right? So it's either going to be the same domain or a much more limited domain range for f. So if f is, say, all real numbers, it's possible for f prime to be all real numbers, or maybe something much more smaller, right? The domain could be smaller than the original f. Okay, please, any questions here? So that's what this point is about. Anybody needs time here? Okay. Now, this is going to be a very interesting technique we are going to develop here. So the question is, we know that if we have a function f, suppose we can get a curve of the function f, right? How do we obtain the derivative graph from the function? How do we obtain the derivative graph, right? So here in example 1, we are given this curve and we are asked to obtain the curve for the f prime. Now, to try and see how this is going to be obtained, let me walk you through some things, right? Some lessons on your previous math classes. You're going to look at the slope of a line. Now, my question is, if a line is like this, what kind of slope do you expect? What is the slope going to be? Is it going to be a positive number or a negative number? If a line is like so.
Negative.
Okay, I have negative. Thank you. Nice. Perfect. Okay, I have a negative number. Okay, cool. Thank you very much. Negative slope. Now, what if the curve is something like so? It's still falling, but it's much steeper. My question is, we understand that if it's falling, then it's a negative slope. But my question is, between these two, the first one and the second one that I graphed, which one will be more negative? What do you say? First one or second one? Which one will be more negative? The slope, I mean. Okay,
second one.
Second, perfect. Second one, right? So this is also what? Going to be, oh, oops, I just skipped. So this is going to be a more negative slope. Okay, perfect job. Very nice. Another question. What if I have a vertical line? What is the slope of a vertical line? Anybody? What is the slope of a vertical line?
0.
So I have 0. Perfect. As I said, feel free, speak your mind. Yeah. Is it undefined? Yes, I have undefined. Okay. So now in this case, I'll say when you have a vertical line, then essentially your slope is undefined. Your slope is undefined. Vertical lines have undefined slopes. Now, if you recall, the slope formula is what? Rise over run. Slope is rise over run. So how come this is undefined? So if it's vertical line, then that means that all the x points are the same. All the x points are the same. Because if I look at a point here, say the point here will be say 2, say 3, 2,3. Another point here will be say 2, another 2,3. The s points, the s coordinates are always the same. No, sorry, not 2,3, 2,4. The y has moved up. right? So let's say 1 point, so 2,4. So the x coordinate remain the same, but the y changes. So if you're doing rise over run, the rise will be a difference in y, which will be, say, a number, right? A number. But then the run will be a change in the x. Since the x's are the same, you always get 0. So you have undefined. So that's just a recap, right? Okay. So now the next thing is, what about something like this? If I have a line like so, then would the slope be negative or positive?
Positive.
Positive. Perfect. Thank you. It's going to be positive. Positive slope. What about something like so? Is it between the two? I know this is positive, but between the two, which will be more positive?
The second one.
Second one. Perfect. Thank you. Because this one is steeper. Okay. So now that you have these are just the building blocks to mastering this technique, right? So let me go down. Let me zoom out. This one I'll need some tools from the PowerPoint. So let me zoom out. Let me first get the. So what you're going to let me first get the coordinate and the x and y axis down here. So what you're going to do is, if you want to get a derivative, just trace the axis down. So let me bring the y axis here. So here, and then the x axis. Let me put it somewhere in the middle. So this is the y, that's my x. And don't forget, for this one, we are just sketching, right? So let me zoom out and then use this tool, the ruler. Okay. So now, please, I hope you can see the PowerPoint. Let me perhaps do this so that it can zoom in a bit. Yeah. Okay. So now we are here, right? So all that we're going to do here is think about if you're interested in, say, the slope of the tangent at this point, right? Oops. Suppose you're interested in, say, the slope of the tangent at a certain point here. Okay, yeah, so this will work. So at this point, so let's start. So we start from left to right, right? So at this point, why is the thing not working? Okay, let me select this. Yeah. So suppose we start from here. The question is, how will the slope look like? So just track your ruler. I used to use a fiscal ruler when we used to teach this in class. But then I figured this out that they have something like this there on the PowerPoint. So this may do. Yeah. So look at the slope of the tangent here. Right? The question is, look at this line. What kind of tangent do you see? Do you see a negative tangent slope or a positive tangent slope based on what we discussed here?
Negative.
Negative. Perfect. Thank you. Jesus, thank you too. Yeah. So it's negative, right? So that means that in this side, right? On this side, down here, the slope, the point that we are going to observe for the slope for f prime is supposed to be in the negative range. Don't forget, for y coordinates, right? From here to here, the y is what? Is positive y. At this point, the y is equal to 0, and then within this interval, the y is what? Is negative, right? So just don't forget that. The same holds for the red axis that I've drawn here. So now, in this part, since if you put your ruler there, you notice that the slope is negative. That means that if you're going to graph this, then it has to be in the negative region. You have to graph it somewhere here. But let's follow through along the line and see how the slope is changing. So that will guide us to how we are going to sketch it. So when I put the ruler back on, right, as I proceed, so here, I have it like this. I know it's negative, but as I proceed along the line, right? So if I proceed, right, as you can see, it's still negative, right? But it's becoming what? Less steeper, right? It's becoming less steeper. You see? So say I track it here. I'm tracking it along the point, right? So say here, I'm tracking it. I'm tracking it along the line, right? So, why is it moving to the ruler? Yeah, technology is nice, but okay, yeah. So let me just show you this. I'm tracking it here along the line, right? So I'm putting like the ruler here along these points and engaging the slope along these points. So that's what I'm doing, right? So I'll do it for the entire curve. So please follow me on that one. So here, we know it's negative, right? When I start at the very beginning, it's very negative. But then as I proceed along, you see the ruler is becoming less steeper, right? less and less steeper, less and less steeper, less and less steeper, right? So that means although it's negative, it's becoming less and less negative. It's becoming less and less negative. That means if you start graphing this line from the negative side, it has to be rising, right? Until I get to an interesting point here. At this point, right? This point here, right? Right here, at this point, what do you see? The slope of the tangent at that curving point, at the curve, is what? You see that the line is what? The ruler is flat, it's horizontal. Oh yeah, so let me add this. I think I didn't add this one. Okay, so draw. So horizontal line. What about the horizontal line? What is the slope of horizontal line? Yeah, let me ask this. Let me add this one. What is slope of horizontal line? It's 0. Perfect. Thank you. Slope is 0. Yeah, so that's what I have to add. Yeah. So at that point, right, at this point, at the turning point, you notice that the ruler is horizontal. So in that case, what is the slope of that tangent line? The slope of the tangent line is going to be what? It's going to be 0. And where on the axis is the y value 0? It's exactly on the x-axis. That means if I'm to track this, at all turning points to that is what is going to happen, right? So at this turning point, the slope of the tangent line has to hit the x-axis. At this turning point too, the slope of the tangent line has to hit the x-axis again. At this turning point, the slope of the tangent line has to hit the x-axis, right? Okay, so now, with the turning points complete, let's check. Let's check. After this first turning point, as you proceed, now you see something interesting happening. The ruler is now rising. In other words, the tangent line is now what? Positive. And it's becoming more and more positive as you proceed, right? As you proceed along the curve, you see that it becomes more and more positive, right? So something like that, until we get to a point somewhere here. And then after that, it becomes less and less positive, getting towards the second turning point. You see, so something like so, second turning point, less and less positive until it becomes 0. So that means when we graph this down here, it has to get out of the negative and become more and more positive, and it will turn somewhere and start decreasing until it hits 0. And then following through for after the second turning point, let's look at the, oops, it's just skipping. Okay, wait. After the second turning point here, let's look at the slope, right? So check it out. The ruler is still becoming, I hope you get the idea now. So let me just continue with maybe a marker or something. So here, right, as you continue, you see that it's now negative again, and it's becoming more and more negative. It becomes more and more negative until a point somewhere here, and then it becomes less and less what? Negative until it hits 0, right? And then after this 0, it becomes positive, more and more 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 positive, right? So that means you go down in the negatives, it becomes less and less negative at some point, and increase, and it becomes more and more positive. So that's how you get f prime of x. And this is the rough sketch. Please, I hope this makes sense. I see something in the chat. Okay, yeah. I hope you're okay here. So you just track it like that. You don't necessarily need a ruler, right? The ruler is just to show you the idea, right? Don't forget you're looking at the slope of the tangent line. And then just imagine like the tangent lines across the curve, and then try and envision whether it should be, say, a positive tangent line. And as you proceed, is it becoming, say, more positive or less positive, or negative or less negative, right? And then from there, you'll be able to construct. So the key points are, at least the key features are, the turning points, it has to hit the x-axis, right? At least. So you can start with those. Hit the turning points at the x-axis. And then between the turning points, you try and figure out what is happening there, right? Okay. Please, are you okay with this? Do you need me to explain this again, or do you have any questions here? Okay, so that's how you get the equation. But later on too, you learn some interesting features, the final 3 features about when you are graphing these things. So that's how you get the f prime from the f. Okay, so now let's go. This graph is just going to give you more notes on what I talked about. So at turning points, you notice that the m is 0, right? The slope of the tangent line is 0, right? So you see 3 turning points here. So at those points, the curve has to hit the x-axis, like you see here, right? And then we continue. You don't need precise measurements of what the slope of the tangent line. This is just an estimate. but you just be sketching. So you get something like this, and then you see that that's the f prime, right? So that's f prime of x. Right, so we ignore this 1.5. It's just saying approximately. You won't be guessing any values. You just be sketching. So we just need to see whether it's in the positive range, and then the turning points hit the what x-axis. That's all. Right. Please, any questions so far on the graphing? So this is just describing the graphs. Any questions? Are you okay? Okay. Now, with that said, so let's look at this question. This question is saying, if f of x equal to square root of x, find the derivative of f. State the domain of f prime. Okay. So now to solve this, let's first find what's the derivative of f. Well, with that one, we know the formula, right? So the formula we've memorized is f prime of x is equal to what? The limit as h approaches 0 of f of what? S plus h minus f of x all over what? All over h. Let me see if I had more room here. Yeah, I have more room. Right, so we start with the formula. And then let's try and find f of s plus h. What's f of x plus h? So go back to the f of x. The f of x is square root of x. So for the f of s plus h, wherever you see x, put in s plus h. So that gives you square root of what? S plus h. Right? So we have f of x plus h to be square root of f s plus h. F of s is just square root of x. So that means that f of s plus h minus f of x will just be equal to what? Square root of s plus h minus square root of x. This time we can't simplify anything here yet. So we have to put everything back together. So the final formula is now what? F prime of s is the limit as h approaches 0 of f of s plus h minus f of s. That's just this. The square root of s plus h minus square root of x all over h. Please, are you okay here? Are you okay with the setup? Okay, anybody needs time here? Or any questions? You are okay with the setup? Yes? No? Wait. Oh, okay. You're okay with the setup? Yes. And then do you need time? No. Okay, Megan, I get it. Okay, cool. And 1 sec. Yeah. So Taylor, let me wait. Please, if you don't understand anything, as I said, let me know. Ask a question. I won't know what's happening at your end until you let me know, right? Okay, perfect. So now let's continue. So that means f prime of x. Wait, do I see something? Oh, you're welcome, Taylor. So f prime of x is what? Limit as h approaches 0. And then for this one, remember that as I said, the derivative will always give you a type 0 over 0. So all that you have to be thinking of is how you're going to factor this. 1 minute to 11. Perfect, Megan. Thank you. Yeah, so I'm coming. 1 minute. Yeah, so maybe after this question, I'll just end. Yeah, after this question, I'll end. Yeah, and then okay, after this, I'll talk about the notation. Okay, yeah. Okay, so now let's continue. So as I was saying, the f prime will always give you a type 0 over 0, right? So you just need to think about how you're going to simplify this and plug in again. For radicals, how do we simplify? We rationalize, right? So that means we have to do square root of s plus h minus square root of x. How do we rationalize this? You just need to what? Multiply the top and bottom by the conjugate. So for the conjugate, we just need to change the minus to plus. So that'll be square root of s plus h plus square root of x. And then all about square root of s plus h plus square root of x, like so. And then you're going to get what? The limit as h approaches 0. And then this one is just a difference of squares. So that'll be square root of s plus h all squared. And then minus square root of x all squared. And then all over what? H times what? Square root of s plus h plus square root of x. Right? So simplifying, you get limit as h approaches 0. And this, the square root and the s squared will cancel. So that'll be s plus h. This minus what? This will also cancel x all about h and then square root of s plus h plus square root of x. Right? And then at this point, the x and x will go off, and then the h will cancel the h down here. Right? Let me use a different color. So the h will cancel the h before when the x's cancel each other out, right? So in the end, we have something like limit as h approaches 0 of what? 1 over square root of what? S plus h plus square root of x. And then when you get here, you just plug 0 for h, right? So wherever you see h, you put in 0. So that gives you 1 over what? Square root of s plus 0 plus square root of x. And then that's finally 1 over what? The square root of x is just square root of x, right? The square root of s plus 0 is square root of x. So square root of s plus square root of s, that's 2 square root of x. And that's our final answer for f prime. Please, are you okay with this? Any questions? Okay. So that's it. Next time that we meet, we talk about these stuff, the other notations and Leibniz and stuff, when a function can be differentiable. And then, yeah, so that's it for today. So let me talk about, no, not for today, right? For the lecture. Now, let me talk about the exam, right, on Wednesday. So you have everything up to, the exam will be from everything up to the f prime of a, like finding something like f prime of a, right? Because you did that last week. I'm not going to emphasize on testing anything for this week, but I mean, this lesson actually overlaps with last week, but it learned everything from 2.1 to f prime of a, that definition. The f prime of a equal to limit as h approaches 0 of f of a plus h minus f of a all over h. This one you have to learn, right? Because this one overlaps when it's just x, because it's the same, kind of like the same formula. If you change a for x, it doesn't change anything, right? So learn up to that point. Now let me go back to what you have to know. That you aren't supposed to leave a square root in the denominator. Oh no, you can leave a square root in the denominator. I don't have it. You can leave a square root. No, for that one, do you know the reason why we rationalize in the first cases? When you're trying to find a limit, right, you get a type 0 over 0. So that's why we rationalize at first. But when you get to the final answer, we don't need to rationalize here because that's the answer to the limit, you see. So yeah, so that's the final one. Okay, you're welcome, Donovan. Okay, please, any other questions here on the lecture before I take this off and go to the exam stuff? Okay, so let me save. Continue. Okay, share screen. Okay, guys, I'm sharing my web browser. If you can't see, do let me know. So we are here, right? So I've provided, okay, let me start with this. So when you go to your files, right, I've provided the study guide, right? You see this folder here, exam 1 study guide. When you open it, you see the study guide, right? With all the questions, right? All questions here. Now, one thing I'll say is please avoid question 7. We have not covered that yet, right? So avoid that. Question 7 is out. Take it out. Don't worry. I know we've covered that. Sorry. We covered that. We've not covered all the aspects, right? We just covered that today. I'm not going to test you on something we did today. I'm going to test you mostly on what we did, even though they overlap, right? The f prime of s, the definition overlaps with what we did in 2.7. So that one, it's possible you see a question like that. You will see a question like that. But for the sketching part, I just introduced the idea today, so I'm not testing you on this. So ignore question 7. But all others are good, right? We learned this way back, I think 2.2. This is like 2.7, right? And then this is something related to like the f prime of the a, question 4. So expect a question. Like so work there for all others except 7, right? For 7, ignore. You don't get any question on that. And then the question 2 and vertical into horizontal, yeah. This one is also coming for sure, right? Question like this, not the same thing, I mean, something similar. Okay, so now with that said, as I said, I have the study guide and I have the solutions here. I try to go step by step, right? So you see the solutions here. All the solutions are here. On Tuesday, however, you have the recitation, which I hope it focuses more on the study guide, right? So please, if your TAs are not here, ask them to do the study guide on that day, right? Yeah, as many questions as they can solve. It would be a good idea to see the question which you have trouble with so that when you go, you can let the TA work it out for you. Now, on the day of the exam, right, I've provided a sample exam. Oh, and good news, for the attendance, I'll be giving bonus on the exam for the attendance. Depending on how many you're able to come. I'll give extra credit on that for like a bonus. I usually give a bonus question, but that attendance will serve as a bonus question. Okay, so I'll communicate that to you maybe on Wednesday. And then assignments, let me see. Yeah, so when you go to assignments, right? Is it 50? Yeah, it's 50. Let me quickly wrap it up. I've provided this thing here, exam, file upload, practice for exam. So since this is your first exam, right? And I don't want you to be overwhelmed with instructions on that day, right? And talking about being overwhelmed, please be on time. I'll start giving the password like 5 minutes early, right? So use this for practice, right? So on the exam, it will look like this, right? What is this asset code? Let me see, is it try? The password is try, I think. Yeah, it's try. Close this. So practice with this, right? The password is try, T, uppercase T, and then RY. And then use this, practice using this, right? So come here, try and upload a file, more than 2 pages, and then practice with it so that on the day of the exam, you won't be lost as to what to do, right? So there's a link to WebAssign. It will take you there. You get on, there'll be part on WebAssign and part on written. So yeah, so that's all on that. Are we taking the exam on our lecture session? Yeah, so we'll be taking the exam on the lecture session, right? Yeah, I mean, it's time, so that's the end. But if you still have questions, you can stick around and ask. So you'll be taking the exam at the lecture session. Yeah, that's true. Yeah, that's all. I mean, yeah.
Are we using anything to proctor it, like Proctorio, or?
Yeah, you have to know, not Proctorio. You have to come on Zoom.
Okay.
Yeah, you have to allow for your mic to allow for background recording, and then like allow for video recording. You have to be on video, you have to allow for, but you have to find a quiet place to take the exam too. That's also important.
Right. Okay. Yeah. Thank you.
You're welcome.
So to upload questions, like to upload your work, your file, you have to upload it, question 1 and question 2.
Yeah, so question 1 and question 2. Yeah, so no, you can't upload like multiple files. So you have to put everything in a single file. Some people like to do it this way. Let me show you one trick. So suppose I have, I've taken pictures, right? Several pictures.
Mm-hmm.
Let me see if I have some pictures I can use. No. I don't have any. These are all personal pictures. I don't have any personal pictures. I don't have any like. Okay, let me see if I have any. Oh yeah, I have some pictures here. Yeah, nice. Okay, let me share my screen. So these are just random pictures in my documents, right? So someone can do this. Word. Blank. After taking the pictures and it's on the PC, you can just copy and paste. Let's say calculus, this calculus picture. I paste it here. That's page 1, right? So maybe that's my first picture. I go to the next page, enter. Yeah. And then let's say this is my second page, right? Let's say this one, that's page 2, right? I paste it there. Oh, drag and drop. Yeah. So you have it here. Do you see? Oh, the first one came. So you can do it this way. And when you're done, you just either send me this file or you can save as a PDF. So save, maybe browse PDF, the desktop, I don't know, doc 1, save as PDF. And then, yeah, so doc 1, you see when you open doc 1, there you have it. So you can have it in this form, you see?
Yeah.
So that's one way. But I don't want to limit you guys. Use whatever you think works out for you. But it will be a single file upload. So when you're done with this, you just have to go, don't save. You just go to your, you come here, right? This one is for the WebAssign. So you have some work on WebAssign and some on the written part. So suppose this is the question, right? So the question will be here. Suppose this is the question to the written part. Like, so this is the question. I mean, I pasted some random stuff. You just choose file and you come to document. Where is it? It's on my desktop, right? DOC, document 1. Like, so you choose it. It will come because I'm the one who set the thing. It's not allowed. Okay, it's allowing. But yeah. So yeah. I thought it was not going to allow me to submit. So upload, it's already here, and then you submit. Right? Yeah. And then for this one, so you do a similar thing here too. Do I see a question? We're taking a picture of our work and uploading it on our phone. I'm not sure. I think it will work if you upload on your phone. It will work, but I don't know whether the one single picture will be able to cover all your work. That's why I'm emphasizing that you learn how to do like uploads with files with more than one page. It's likely you'll be working more than one page for the WebAssign and then for this, right? That's what you do for, yeah, perfect. That is really why the quizzes are also set up in that way, so that it prepared you for this. So that when you get here, it's not all new. You see, yeah, that's why the quizzes were set up like that. Perfect, yeah. So it's good you have experience. I knew you have experience based on the quizzes that you can use to scan. Yes, you see, you even have, yeah, you can even have like something on your phone to scan. So it's up to you. That's why I said I don't want to limit you guys as to what kind of thing you can do, right? So do whatever. The technology is so expanded. There are some I don't even know about, which may be very convenient for you. So use whatever, but just learn how to upload something with more than one page, because you have to upload a single file, right? So single file for WebAssign work and single file for the question 2. There are only 2 tabs, right? So for each of them, put all your work on one file and then upload. Yeah, in Notes. Yeah. Yeah. So I won't limit you. Use whatever works for you. Okay. Any other questions?
Will we need our student IDs or something like that to check prior to the exam?
Could you please come again? Will you need a?
Will we need our like student IDs or some type of ID to compare?
Yes. Yeah. You need a student ID, right? I think I sent an email and I gave all the instructions. So I also advise that you go and look at it again, right? For that one, I thought it out and thought about all the things you need to know, right? So I put everything there, right? I put everything there, like even the password to this one, to this try thing. I talked about this, the fact that I have this provided. The password is uppercase T R Y, lowercase RY, right? So all the information is there. Your ID too, you need everything, yeah, because I don't know all your faces by now. If it was in class, I will learn everyone's name, but since you guys are online, I only get to see a couple of people. So I don't know all of you, right? Yeah, so please bring your ID card on that day, on Wednesday.
Okay, sounds good. Thank you.
Yeah. You're welcome, mother. You guys are free to schedule like questions. If you want me to solve some of the questions you don't understand, feel free to reach out. I'll make time for you. Yeah, I think someone was going to talk. Or someone has a question.
All right, Nadeep, thank you.
You're welcome, Daniel. See you. So I'll be here till the last person. Yeah, Shane, you have a question. Oh, you're welcome.
Yeah, come out here. Have a good day.
Same to you.
Yep. Thank you, Professor.
You're welcome, Hunter. You're welcome, Ahmed.